Welcome to the deep dive. Today, we're really getting into something fundamental in Java inheritance.
Yep, it's absolutely key, especially if you're aiming for those senior roles or just want to build, solid, maintainable systems.
Exactly, and it comes up all the time in interviews. So we're focusing on how Java lets you control that inheritance.
Precisely. We'll be looking at the final keyword, the abstract keyword, and also the protected access modifier.
The goal here isn't just syntax, right? It's about understanding the design implications.
Absolutely. So if you're prepping for that next interview or just leveling up your Java game, this deep dive should give you that clarity.
Let's do it. We'll use practical code examples, pull out those interview-worthy insights. Where should we start? Maybe with final.
Sounds good. Let's start with final methods. So when you put final on a method, you're basically locking it down.
Locking it down how?
It means no subclass can override that method. The implementation you provide is, well, final. Take this example. Public, final string, get name, return name. Let's walk through that. You've got public, then final, return type string, method name, get name, open and close parentheses.
Right.
Then an open curly brace, the statement return name, with a semicolon and a close curly brace.
So that getName method, if it's in, say, an employee class.
Then any class that extends employee cannot provide its own version of getName. It has to use the one from employee.
Makes sense.
Yeah.
Is there a common example of this in the core Java libraries?
Oh, definitely. Think about the get class method. It comes from the object class, the root of everything.
Ah, right. Object.getClass.
Yeah, and it's final. You really wouldn't want subclasses to be able to lie about what class they actually are, right? So Java prevents that. It's fixed.
Good point. Now, I've heard people talk about final and performance. Is that still a thing?
Ah, that's an interesting historical footnote, really. Back in the early days of Java, maybe there was a slight performance edge because the compiler knew for sure the method wouldn't be overridden.
So it could optimize more easily, like inlining.
Exactly. It could perform inlining, basically pasting the method's code right where it's called. But modern JVMs, they're incredibly smart.
Okay.
They often do speculative inlining even for non-final methods. They'll inline it, assuming it won't be overridden.
But what if it is overridden later when a subclass gets loaded?
The JVM can actually detect that and undo the inlining. It's quite sophisticated.
Wow. So using final just for a potential tiny speed boost isn't really the main reason anymore?
Not really, no. The main reasons now are about design and intent. And actually, there's some debate about how much to use final.
Oh, different opinions.
Yeah. Some developers argue you should make most methods final by default. Their thinking is, unless you specifically design a method to be extended or overridden, you should lock it down to prevent unexpected changes in subclasses. It promotes stability.
I can see the logic there. Predictability.
Right. But others find that way too restrictive. They argue it prevents potentially harmless or useful overrides, like maybe adding some logging inside a method in a subclass for debugging.
Yeah. If the original method is final, you just can't do that easily.
Exactly. So it's a design trade-off, really. How much flexibility versus how much control. There's no single right answer. It depends on the context.
Okay, that's final methods.
Yeah.
What about applying final to a whole class?
Yeah. So final on a class means you cannot create any subclasses of it, period. It's the end of the line for that inheritance branch.
It's like putting up a do not extend sign?
Pretty much. It's like saying the class is complete as it is. Consider this. Public, final class, executive, extends manager. You have public, then final, then class, the name executive, it extends manager, open curly, close curly.
So nothing can inherit from executive. It's the final word. Literally.
Exactly. It cannot be a superclass. It's like declaring a feature request final, no more changes.
Huh. Got it. Are there well-known final classes in Java itself?
Oh, absolutely. The string class is probably the most famous example. It's final.
Right, string is immutable and final.
Yep. Also classes like local time from the datetime API or URL. Making these final often helps ensure things like immutability, which simplifies reasoning about code, and it can also be for security preventing malicious subclasses from messing with fundamental behavior.
Okay, that covers final pretty well. Let's switch gears to abstract. This seems like the opposite philosophy in some ways.
It is, in a sense. While final prevents extension or overriding, abstract often requires it. An abstract method is essentially a placeholder.
A placeholder how?
It's declared, it has a signature name, parameters, return type, but no implementation, no method body, no curly braces.
Okay.
The keyword abstract is used for the method, and critically, any class that contains even one abstract method must also be declared abstract.
So the class itself becomes abstract too. Why do this?
It's a way to define a common template or contract for a group of related subclasses. The abstract class says any real concrete version of me must provide an implementation for these specific methods. Let's look at an example. Public abstract class person, private string name, public person string name, public person string name, this dot name get out. Public final string get name, public abstract in get it.
All right, let's unpack that. Public abstract class person, open curly brace.
Inside, we've got private string name, semicolon, standard field.
Then a constructor, public person, string name, open parent, string name, close parent, open curly, this dot name, semicolon, close curly. That looks normal.
It is. Abstract classes can have constructors, which are typically called by subclass constructors using super.
Okay, then there's a final method. Public final string get name, open parent, open curly, return name, semicolon, close curly.
Exactly. This shows an important point. Abstract classes can have concrete methods, even final ones. They don't have to be purely abstract.
That's a key difference from interfaces, especially pre-Java 8, right? Interfaces couldn't have instance variables or concrete methods back then.
Precisely. Abstract classes can have state, instance variables, and provide some default or fixed behavior alongside the abstract methods.
And then the core part, public abstract, ingetted, semicolon, no curly braces.
That's the abstract method. It declares that any concrete subclass of person must figure out how to provide an integer ID. The person class itself doesn't know how, so it delegates that responsibility. And because it has this abstract method, the person class itself must be marked abstract. Finally, the class definition ends with a closing curly brace.
Okay, so person is incomplete. Does that mean I can't create a person object directly?
You got it. Trying to do person P, you get new person, Fred, semicolon. That's a compile time error.
Compiler says no.
Right. You can't instantiate an abstract class. It's like trying to use a blueprint as if it were the actual building. It's not finished yet.
So how do we actually use person then?
Through concrete subclasses. You create a class, say student, that extends person, and student must provide the implementation for getId.
Let's see that.
Okay, so public class student extends person, private int id, public student, string name int id, public int get it id.
All right, let's trace this. Public class student extends person, open curly. It adds its own field, private int id, semicolon.
Then the constructor, public student, string name int id, open parent parameters, close parent, open curly. First line calls the superclass constructor, supername, semicolon.
Passes the name up to person. Makes sense.
Then it initializes its own field, this. Sani ID equals id, semicolon. Close curly for the constructor.
And here's the crucial part, implementing the abstract method.
Yep. Public int getId, open parent, open curly. It provides the body. Return id, semicolon, close curly for the method, and one more close curly for the class student.
So now student is a concrete class because it implemented getId.
Exactly. And now you can create instances.
Yeah.
And you can use polymorphism. You can write person P, new student Fred, 1729, semicolon.
Okay. You create a student object, but you store it in a variable of type person.
Right, because a student is a person. It fulfills the person contract, including having a getId method. This is super powerful for writing flexible code.
Got it. Abstract classes define the what, concrete subclasses define the how. Now let's talk about controlling access within these hierarchies. Let's talk protected.
Right. Protected is an interesting access modifier. It sits somewhere between private, only accessible within the same class, and public, accessible everywhere.
So who can access a protected member?
Two groups, basically. First, any subclass can access protected members of its superclass, even if the subclass is in a different package.
Okay, subclasses get access across packages. What's the second group?
Second, any class within the same package as the class with the protected member can access it. This package-level access is a key Java-specific aspect of protected.
Okay, so it's subclass access plus package access. What's the main use case?
Often, it's used when you want to expose something to subclasses, maybe a helper method or an instance variable, but you don't want it to be part of the public API for everyone else.
Give an example.
Sure. Imagine our employee class, again, maybe in a specific package. Package com.horseman.employees, public class employee protected double salary. Package declaration package, com.horseman.employees, semicolon, class definition, public class employee, open curly, inside, protected double salary, semicolon, close curly.
Okay, so salary is protected. Subclasses and classes in com.horseman.employees can see it.
Now let's define a manager subclass in a different package. Package com.horseman.managers, import com.horseman.employees, employee, Public class manager extends employee, private double bonus, public double get salary, return salary plus funding
Colon.
amount.
Packagecom.horseman.managers, semicolon. Importcom.horseman.employees. Employee, semicolon. Class, public class manager extends employee open curly. It has its own private double bonus, semicolon.
And then the method. Public double get salary, open parent, close parent, open curly. The implementation is return salary plus bonus, semicolon, close curly for the method, close curly for the class.
And the return salary plus bonus line works, even though salary is an employee in a different package.
Yes, because salary is protected in employee and manager is a subclass of employee. So the manager object can access its own inherited salary field directly.
Okay, that shows the subclass access across packages. But you mentioned a restriction.
Ah, yes, a very important one. A method in a subclass, like manager's get salary, can access the protected members of the object it was called on, i.e. its own inherited members, but it cannot generally access the protected members of other employee objects.
So a manager object can see its own salary, but it can't just reach out and peek at the salary of some other employee object it might have a reference to.
Exactly right. If you had employee, other new employee, inside the manager class, you generally couldn't say other.salary. This prevents subclasses from becoming sort of like privileged snoops into the state of arbitrary superclass objects. It maintains better encapsulation.
That makes sense. It sounds like using protected fields needs some care, though.
Definitely. Exposing fields, even as protected, creates a strong coupling. If you make salary protected, all subclasses might start depending on its exact type and existence. If you later want to change how salary is represented in employee, maybe change the type or calculate it differently, you could break all those subclasses.
So it makes future refactoring harder.
Much harder. That's why protected methods, or sometimes protected constructors, are often considered safer bets than protected fields. Let the subclasses interact through methods, not directly with the internal state.
You mentioned object.clone being protected earlier.
Yeah, clone is a classic example of a protected method in the core API. Its whole mechanism is quite complex, actually, maybe a topic for another time, but being protected is part of its design.
Okay. And just to reiterate that Java nuance one more time.
Yes, remember, protected in Java means accessible to subclasses, any package, and D accessible to any class in the same package. That package access part is crucial and sometimes trips people up if they're coming from other languages.
Fantastic. That clears up final, abstract, and protected quite a bit. Now, thinking about those senior interviews, how might these concepts actually show up in questions?
Oh, they definitely will. Interviewers want to see if you understand the why behind these, not just the what.
So what kind of questions?
You might get something direct like, explain the difference between a final method and a final class. When would you use each?
Okay. Test understanding of both uses of final.
Or, describe an abstract class and an abstract method. Can an abstract class have concrete methods? Why might you choose to make a class abstract instead of, say, using an interface?
That one probes the core concept and the comparison to interfaces.
Right. And definitely expect questions on access modifiers. How does protected differ from private, public, and default package private access? Give a scenario where protected is the appropriate choice.
Tests the nuances of visibility.
They might also throw quick checks like, can you override a final method?
And the answer is
A clear, no, it causes a compile time error. Trying to override a final method is like trying to argue with the architect after the blueprints are signed off. Not going to happen.
Good analogy. What else?
Can you instantiate an abstract class directly? Why or why not?
Again, that's a no, because it's incomplete.
Exactly. Understanding protected access with its subclass and package visibility. Sometimes it feels like trying to figure out the permissions on a shared drive, you know? Who actually has access here?
Yeah, that tracks. It can be more open than you first think.
So being able to articulate these differences and trade-offs clearly is key.
Absolutely. So let's quickly recap the big takeaways from this deep dive.
Sure. We saw final is about preventing change, stopping method overriding, or stopping class extension altogether. Designed for stability, sometimes immutability.
Then abstract is about defining contracts, forcing subclasses to provide specific implementations while potentially offering some shared fields or concrete methods, designed for mandatory specialization.
And protected is that intermediate access level for subclasses across packages and for any class within the same package. Useful for controlled extension, but use with caution, especially for fields.
And knowing this isn't just trivia. It's fundamental to designing good object-oriented systems in Java and, crucially, for for demonstrating that senior-level understanding in interviews.
Precisely. Discussing these with accuracy, explaining the design rationale, that's what interviewers are listening for.
Definitely. Okay, now for you listening, think about your own experiences.
Yeah.
Have you ever had to make that call final or not? Abstract class or interface, protected or something else?
Yeah, what was the situation? What trade-offs did you weigh up?
We'd love to hear about it. Head down to the comments section and share your story and your reasoning. It's a great way for everyone to learn from real-world scenarios.
Absolutely. Engaging with these ideas and discussing them really helps cement the understanding.
Well said. That brings us to the end of this deep dive. Keep digging into these Java concepts.
And we'll catch you on the next one.